Hello, our second lesson on factoring is called Factoring Special Products, and this is lesson 8-2. Today, we're going to factor a perfect square trinomial. We're going to factor a difference of two squares, and finally, use complex numbers to factor a sum of squares. So we get this office building back from the previous lesson, and it says in the diagram below, the conference room has a length and width of X units, and each cubicle has a length and width of 1 unit. So what we're going to do is represent the area of the entire office as a sum of the areas of all the rooms. Well, we know that we can do that with, kind of using the algebra tiles that we learned about when we were working in activity 4. So x times x, we know this has got to be an area of x squared. 1 times x makes this one x. So all these long ones are going to be x because they're all 1 times x for their areas. And the little cubicles, they're like ones, 1 by 1. So if we add all these together, we can represent the area of the entire office. We've got an x squared plus 6 x's, and then we have 9 little cubicles, so 9 ones. Now, what we want to do is, since we're working on factoring, is we really want to represent this as a product of two binomials. So if we think about creating expressions of binomials that represent the area, we're looking at the length and the width, we can see that, across, on the side here, we've got an x and 3 ones. So that's having, x and then, plus 3. Well, it's the same across the bottom, so the length is going to be the same. It's going to be x plus 3 ones, so x and 3. So this actually can be expressed as x plus 3 times x plus 3. Now, what property can we use to show that the expressions in items 1 and 2 are related? Well, we should be able to use FOIL to do that. X times x is x squared. Outers are 3x. The inners are also 3x. And the last is 9. So that is x squared plus 6x plus 9. That's, we use distributive property, but we call it FOIL for the method that we use. And so that's, we're going to be working on some backwards FOIL so we can get from the trinomial back to the two binomials to factor. Okay, so we could practice a couple more of these. We have, looks like we have x plus 1 as our length and x plus 1 is our width. So x plus 1 times x plus 1, we'll get x squared, and then we get 1x plus 1x is 2x, and 1 times 1 is 1. And let's just look at one more. Looks like we have x plus, now this is going to be 4 going across, there's 3 more of those. So it looks like we're going to have x plus 4 times x plus 4, which is x squared plus 8x plus 16. So these expressions that we have that we're looking at, they are all going to represent what we call perfect square trinomials. If you look at all 3 of these expressions and you look at their factored forms, notice that their factors are identical. Okay, so just like perfect square numbers have identical factors, you think about 25 as a perfect square because it's 5 times 5. And 16 is a perfect square because it's 4 times 4. Well, trinomials can be perfect square trinomials also if they have identical binomial factors. And so we want to get to recognize these perfect square trinomials so that we can factor them very quickly. So there's some things you want to look for, okay, and that's what we'll talk about in the next little table. Okay, so in number 5, if we see some of these, we could do some of these little FOILs and we can kind of represent our trinomial. We can kind of look and see, well, maybe what are some patterns that we'll observe. So in our first row, that's that x squared plus 6x plus 9. Notice that each term in the first term in each factor is x, and the second term is 3. Well, in the next row, we've got x, of course, but then we've got negative 3. Okay, and so let's just fill out those 2 columns. They'll go pretty fast. There we've got x and 4. We're going to look at x and negative 4, how they're related. We've got x and 5, and then we're going to look at x and negative 5. So if we were to FOIL x minus 3 times x minus 3, it's almost the same as x plus 3 times x plus 3. There's just one difference. So that's going to be x squared. This time it's negative 3x and negative 3x, which makes negative 6x. But it's still positive 9 because negative 3 times negative 3 is positive 9. So there's only a difference there of the sign in the middle. Okay, so when we look at x plus 3 times x plus 3 versus x minus 3 and x minus 3, their trinomials are very close. Okay, so let's look at that same concept here, but let's use the x plus 4s this time. So x plus 4 times x plus 4 we know is x squared plus 8x plus 16 is 4x, and 4x is 8x. Well, if those two factors had negative 4s, well, then it would just change to x squared minus 8x plus 16. Okay, same with the x plus 5s. We could do the same thing. If it's x plus 5 times x plus 5, that gives us x squared plus 10x plus 25. And it'll only change to minus 10x plus 25. So that's going to be true for all of our perfect square trinomials. They're going to have these identical binomial factors, and we want to pay attention to their signs. Okay, so one of the things I want you to notice is that the middle term of the trinomial is always twice the constant term of the binomial. Okay, so the middle term, okay, like that negative 6, okay, is twice the constant term, which was negative 3 in that example. Okay. So now we'll get our rule. So our official rule for perfect square trinomials is if you take a squared plus 2ab plus b squared, and you also have a squared minus 2ab plus b squared, all we have to do is write the two factors, and the positive one, you're going to have a plus b times a plus b, because you always double the a times b. And for a squared minus 2ab plus b squared, you'll have a minus b times itself, a minus b. And again, the outers and the inners double, but this time we're doubling a negative number, and that's why it's negative 2ab. Okay, and so we call these our perfect square trinomials. Okay. So we should be able to factor these pretty quickly. So we're going to do the check your understanding. So we can see 3 of these in action here. So number 8, let's start with that one. So number 8, we have x squared minus 14x plus 49. Okay, so if we think about, the number that would multiply to 49, but double to negative 14. And so you would hopefully figure out that that has to be x minus 7 times x minus 7. Because the outers, negative 7, plus the inners, negative 7, make negative 14. And negative 7 times negative 7 is 49. Now, if we look at a number like 100, we should be thinking about the number 10. Because 10 times 10 is 100, and 10 plus 10 is 20. So we're going to go with m plus 10 times m plus 10. And finally with 64 and negative 16, with 64 and 16, hopefully you're thinking about the number 8. But negative 8 this time, because y minus 8 times y minus 8, negative 8y and negative 8y make negative 16y. So we just got to pay attention to the signs. So that's really the first part of the lesson, is working on the perfect square trinomials. The second part of the lesson, notice that our factors in this table are not identical. They're close, okay? We have x plus 3 times x minus 3. And hopefully you remember that when you multiply these, we call them conjugates, when you multiply these, the outers and the inners cancel. And we just get x squared minus 9. And then for our next one, we get x squared minus 25. Okay, for the third one, we get 81 minus x squared. Okay, and the next two, have coefficients, but we still only have to multiply the first and the last because the outers and inners will cancel. So we get 4x squared minus 49, and we get 36x squared minus 4y squared. So all of these polynomials are a difference. They all have subtraction signs, and they're all a difference of 2 squares. They're all perfect squares or perfect square expressions in there. And so you can see that whenever you have a perfect square expression, like 36x squared minus 4y squared, it's going to factor into 2 binomials that are not identical. Instead, they're conjugates. You get one with negative and one with positive. And you just have to take their square roots. Okay. So let's practice a couple of those. So in number 13, they start talking about, they give us an expression and then they want us to write the factors. They gave us one factor though. So one factor is 6 plus y. So since it's a difference, 36 minus y squared, if one of the factors is 6 plus y, the other one has to be 6 minus y. Those are our conjugates. And if one factor of p squared minus 144 is p minus 12, well then the other one has to be p plus 12. Okay, so let's practice that on number 14. So number 14, we have 49 minus x squared. So I notice that 49 is a perfect square, and so is x, and it's a difference. So we can factor this as 7 plus x and 7 minus x. So one of each, one positive quantity, one negative quantity. And n squared minus 9, we have n, and we have 3. So we'll do one positive, n plus 3, and one negative, n minus 3. And 64w minus 25, we're going to have, again, one positive and one negative. Well, for 64w squared, we're going to have to use 8w. So 8w plus 5 and 8w minus 5. And we can check all of these with FOIL, and you should notice that outers and inners will cancel. So number 15, we'll get our pattern. Anytime you have a polynomial in the form of a squared minus b squared, it will always factor into 2 quantities, one positive, one negative, but we have to take their square roots. Okay? And we call this the difference of 2 squares. So a squared minus b squared is the difference of 2 squares. So to stay organized, I try to usually identify my square roots first. So like in number 16, if I have x squared minus 121, I know my a would have to be x, and my b would have to be 11, because those are the square roots of x squared and 121. And then I just make one positive and one negative quantity. So x plus 11 and x minus 11. 16m squared minus 81, I can see my a is going to be 4m and my b is going to be 9, because those are the square roots. So I'll have a 4m plus 9 and a 4m minus 9. And finally, we have 9 minus 25p squared. So a is 3, which is the square root of 9, and b is 5p, which is the square root of 25p squared. So 3 minus 5p times 3 plus 5p. And that's all you have to do to factor a difference of squares. So the last little part of this is really kind of an extra with factoring, more of a challenge, because we don't typically factor the sum of 2 squares. It doesn't factor nicely like the difference of 2 squares does. Instead, the sum of 2 squares factors into some imaginaries or complex expressions. So we're going to pick that up on the next page. So if we had something like this, factor p squared plus 9q squared, well, that's not really something we can factor using the difference of two squares. It's not a difference. However, we could write it as a difference, and if we did that, we would have to change the signs. So if I decided to make it I wanted to go from plus to minus, I would have to make it minus a minus, and that's what you kind of see here. So p squared plus 9q squared is p squared minus a negative 9q squared. Well, we could rewrite negative 9 as 3i. And we're allowed to do that because remember, I squared equals negative 1. So if we do that, we could actually put it all together as 3iq squared. Then you can factor it as p minus 3iq and p plus 3iq. So we don't usually see these problems very often, but we'll work through one of them just so you can see how it would look. So our first one, x squared plus 16y squared, is not a difference of squares. However, we could rewrite it as x squared minus a negative 16y squared. Okay, that's still x squared plus 16y squared. And then if we were to replace 16 with 4i squared, well then we could rewrite this as x plus 4iy and x minus 4iy. So really all you're doing is you're adding in an I in this situation. And the factors are, they involve imaginary expressions, and so they're not super useful, so we don't use them that often. So for the last one, if you think, if you just think, okay, it's 5x squared, okay, so that's got to be, or it's 25x squared, so it needs to be 5x, and it's 36, but it's plus. So if I change it to an I, it'll work. So 5x plus 6yi and 5x minus 6yi. So we will work on some practice problems again in class. We'll use some of these practice for our classwork, and then we have an attached